This is lecture 4, theory building. By the end of this lecture, you should be able to explain what a dependent variable is and what an independent variable is, understand the differences between binary variables and continuous variables, write an argument that explains how and why an independent variable should influence a dependent variable, derive hypotheses from your arguments, draw the hypothetical relationship between two variables on a graph, and read and summarize political science theories set/hypotheses. Now that you know how to collect and measure and describe variables using simple statistics, I'm going to start teaching you how to engage in the scientific process in political science research. Recall that in the first step of the scientific process, we choose a specific outcome of interest to focus on. This outcome of interest is called the dependent variable. It's called a variable because we examine cases where the outcome varies. For example, imagine our dependent variable was democracy level of a country. It would vary because some countries would have high democracy levels and some would have low democracy levels. We would want to know why some countries have high democracy levels while others do not. Next, recall that in the second step of the scientific process, we identify one factor that influences our dependent variable. That factor is called the independent variable. We expect that variations in the independent variable cause variations in the dependent variable. In other words, changes in the independent variable come first, and changes in the dependent variable come second and are the result of changes in the independent variable. For example, imagine our dependent variable was democracy level and our independent variable was oil wealth. We could expect that as the independent variable oil wealth changes, we should see changes in the dependent variable democracy level. Normally, we are more specific about how the changes in the independent variable cause changes in the dependent variable. So for example, we could expect that as the oil wealth of a country increases, the country's democracy level should decrease. Now I'm going to show you how to write a theory. First, make sure you have properly identified your dependent and independent variables. Then describe how changes in the independent variable lead to changes in the dependent variable. Make sure to explain why changes in the independent variable lead to changes in the dependent variable. Within your discussion, make sure to show how all the possible variations in the independent variable lead to all the possible variations in the dependent variable. Note that it should take several paragraphs to write a proper theory describing how variations in the independent variable should cause changes in the dependent variable. Now I'm going to show you some brief examples of models that are poorly written and well written. Here is an example of a model. In this study, we focus on explaining why some House candidates use party symbols while running for office while others do not. We argue that personal level factors such as gender influence how candidates use party symbols. What is the dependent variable? Use of party symbols while running for office is the dependent variable, as it is the outcome of interest the authors are trying to explain. What is the independent variable? Gender is, as gender affects the use of party symbols in House elections. An easy way to identify which factor is the independent variable and which factor is the dependent variable is to draw a diagram like this and place the names of the variables here with an arrow in between. Changes in the independent variable will always precede changes in the dependent variable. Now, how does gender affect the use of party symbols? Are men more likely to use them or women? We cannot tell from this paragraph. Since we do not know how gender affects the use of party symbols in House races, this is a poorly written model. Here's another model. This article analyzes the use of vetoes in presidential systems. We argue that landmark legislation is more likely to be vetoed than non-landmark legislation. What is the dependent variable? The use of vetoes in presidential systems, as it is the outcome of interest the authors are focusing on. What is the independent variable? Landmark or non-landmark legislation, as the type of legislation influences the use of vetoes. How does the independent variable influence the dependent variable? Landmark legislation, is more likely to be vetoed than non-landmark legislation. So we know how landmark legislation influences vetoes, but do we know why? We cannot tell from this model, hence this is a poorly written model. And here is another model. In this paper, we investigate the impact of cell phone technology on violent collective action. We argue that the availability of cell phones allows political groups to overcome collective action problems more easily and coordination issues. Utilizing data on cell phone coverage and the location of organized violence events in Africa, we are able to show that the availability of cell phone coverage significantly and substantively increases the probability of violent conflict. What is the dependent variable? Use of violent collective action, as it is the outcome of interest the authors care about. What is the independent variable? Cell phone technology, as it influences whether violent collective action takes place. How does the independent variable influence the dependent variable? As access to cell phones increases, the use of violent collective action increases. Why does the independent variable influence the dependent variable that way? Cell phones allow groups to overcome collective action problems and coordination issues when they are organizing collective violence. As you can see, this is a very well written model. After reading it, you can identify the dependent and independent variables. You can also explain how the independent variable influences the dependent variable and why the independent variable influences the dependent variable that way. Please note that while this is a very well-written theory, most well-written theories tend to be pages long. When you write a theory, you should explain in great detail how and why your independent variable should influence your dependent variable. Next, recall that the third step in the scientific process is to derive hypotheses from our models. Recall that a hypothesis is a one-sentence statement we derive from our model. It tells us how variations in our independent variable lead to variations in our dependent variable. Note that it shows how all the possible variations in the independent variable lead to all the possible variations in the dependent variable. This hypothesis should be testable or observable in the real world, meaning that we should be able to collect data to determine if the hypothesis correctly identifies the relationship between our independent and dependent variable in the real world. After you write your model, if you cannot write a hypothesis based on the model, it probably means you need to rewrite your model. There are several different ways to write hypotheses. I'm going to discuss a few templates you can use to write your hypotheses. You can use the more likely than / less likely than template. It is generally useful when you have dichotomous independent and dependent variables. Dichotomous means that the variable only has two categories or values. Many nominal and ordinal level variables take on only two values. Here is a good example of how we can apply the more likely than / less likely than template. The independent variable gender is dichotomous as it only has two categories, women/men, and the dependent variable party identification is also dichotomous as it only has two categories, Democrat and Republican. Using this template, we can write the following hypothesis. Women are more likely than men to identify as Democrats. Note that this hypothesis illustrates how variations in the independent variable, women versus men, influence variation in the dependent variable, Democrat versus Republican. Women are more likely than men to identify as Democrats versus identifying as Republicans. You can also use the more than / less than template. It's generally useful when we have a dichotomous independent variable and a continuous dependent variable. Recall that dichotomous means that the variable only takes on two categories or values. Many nominal and ordinal level variables take on only two values. A continuous variable is a variable that takes on more than two values and is ordered. Any ordinal, interval, or ratio level variable with more than two values is a continuous variable. Here is a good example of how we can apply the more than / less than template. The independent variable type of institutions is dichotomous because it only has two categories, democracy and dictatorship. And the dependent variable defense spending is continuous because it can take on any value between 0 and a positive value. In this example, we could use the template to write the following hypothesis. Dictatorships allocate more resources to defense spending than democracies. Note that in this example, our hypothesis includes information about how variations in the independent variable, dictatorship/democracy, lead to variations in the dependent variable, more spending versus less for democracies. You can also use the independent variable increases/decreases, dependent variable increases/decreases template. This template is generally useful when you have continuous independent and dependent variables. In this example, both defense spending and per capita income are continuous as they can take on any value between 0 and a positive number. Using this template, you can write the following hypothesis. As the per capita income of a country increases, the amount of resources the government spends on defense increases. Note that this hypothesis identifies how variations in the independent variable per capita income increases lead to variation in the dependent variable defense spending increases. Here are some common mistakes when writing hypotheses. The first poorly written hypothesis states some countries are more likely to go to war than others are. The hypothesis does not indicate how variations in the independent variable lead to variations in the dependent variable. Some countries are more likely to go to war than others, but which countries? What factor influences whether a country goes to war? In the corrected version of this hypothesis, it is clear that political institutions influence whether a country goes to war. Dictatorships are more likely to go to war than democracies. The second poorly written hypothesis states, wealthy countries have high standards of living. In this hypothesis, there is no variation in the dependent or independent variables. With respect to the independent variable, wealth of a country, the hypothesis only focuses on wealthy countries and does not reference poor ones. With respect to the dependent variable, standard of living, the hypothesis only focuses on countries with high standard of living and does not reference countries with low standard of living. Based on this hypothesis, it is clear what we should expect to happen in poor countries. Do they have low standards of living or high standards of living? To write a better hypothesis, we could write, wealthy countries have higher standards of living than poor countries. Now we know that we expect poor countries to have lower standards of living. If you want to know if you wrote an appropriate hypothesis, you should draw a graph of the relationship between your independent and dependent variables. If you cannot draw this graph, it means you need to rewrite your hypothesis. In order to draw the graph, you draw a y-axis and label it with the dependent variable name, and an x-axis and label it with the independent variable name. Place the appropriate value labels on the axes and draw a line illustrating the relationship between the two variables. Here is an example of how to draw a graph based on a hypothesis. Consider the following hypothesis. As the per capita income of a country increases, the amount of resources the government spends on defense increases. The dependent variable in this hypothesis is defense spending. It can range from 0 to billions of dollars. The independent variable in this hypothesis is per capita income. It can range from 0 to about 60,000. This is a graph of what this relationship would look like. The dependent variable defense spending is on the y-axis, and the independent variable per capita income is on the x-axis. Each axis is labeled with the appropriate numerical values, and since our hypothesis suggests that as per capita income increases, defense spending increases, we should draw a line with a positive slope on this graph to illustrate that as per capita income increases, defense spending increases. Note that even if your hypothesis allows you to draw a graph of the hypothetical relationship between your two variables, that only means that your hypothesis tells you how your independent variable influences your dependent variable. It does not tell you why your independent variable influences your dependent variable that way. There are many different types of relationships between independent and dependent variables. The one we just focused on was linear, meaning that as our independent variable increases, our dependent variable increases or decreases at a constant rate. As you can see in the slide, there is a positive linear relationship between the independent and dependent variables. As x increases, y increases at a constant rate. As you can see in this slide, there is a negative linear relationship between x and y. As x increases, y decreases at a constant rate.